Welcome back. We're continuing talking about capacitance, and this time here I'm saying building a capacitor, and I am using this topic here. I deliberately wrote that topic there because this time we want to know, with the specifications that are given to us, how do we build a capacitor so that we can meet the requirements in that particular electric circuit board of your television set or your radio. They tell you at this point, the capacitor we need for this point must be 13 microfarads. Okay? Can we work from that specifications and use the materials that we have at hand to build that capacitor? The answer is yes, because all we need to remember, earlier I said the capacitance of the capacitor depends on the area of the the area of the parallel plates, the distance between them, and the permittivity constant that you're going to use. If you're going to use free space between the parallel plates, then the permittivity constant becomes that one. Okay? Now, let's look at this example here. The dimensions of the plates in a parallel plate capacitor are 20 millimeters by 4 millimeters. The distance between the plates is 15 millimeters. Calculate the capacitance of this capacitor if the plates are separated by free space. Okay, now, free space. Now let's look at this. Capacitance is E naught, okay, A over D. Now we are given, if we're looking at free space, okay, what is the value of E naught? It's that one, 8.85 by 10 to the power 12. 8.85 by 10 to the power minus 12, actually. Okay, coming to the others, area is 20 by 4 and the space between them is 15 millimeters. So this will be times the area 20 millimeters, 20 by 10 to the power minus 3, okay, times 4 by 10 to the power minus 3, because the area here is length times breadth. We've got the length and the breadth. Length is 20, breadth is 4. You divide all these by the distance between the plates. It's 15 millimeters, so it's 15 by 10 to the power minus 3 in meters, because we work in meters. You know that. Okay, so let me work this out for you quickly. It's 8.85 by 10 to the power minus 12 times 20 by 10 to the power minus 3 times 4 by 10 to the power minus 3, okay, divided by 15 by 10 to the power minus 3. And what is the answer? We find the capacitance here to be 4.72 by 10 to the power minus 14 farads. Okay, you can put capital letter F there for farads. So that's how you would work that one out. Another example, a certain capacitor, okay, is marked 1.2 microfarads and contains air as its dielectric. Calculate the distance between the plates of this capacitor if the dimensions of the plates are 12 millimeters by 4 millimeters. Now, capacitance again, permittivity constant times A over D. Then if this is 1.2 microfarads, then you're going to say 1.2 by 10 to the power minus 6 micro equal to, E for free space is 1, okay, 1 times the area, 12 by 10 to the power minus 3 times 4 by 10 to minus 3 divided by D, which is the distance between the plates, okay, is what we're calculating for, so we'll put a D there. So how will you do this? You will just say, okay, 12 by 10 to minus 3 times 4 by 10 to minus 3 equals, okay, and then this, if you divide that by 1.2 by 10 to minus 6, that gives you the distance between them. It's 40, okay? But this D here may not be too realistic. It is just a way for us to try and see how to calculate for those things. Okay, now that's what it is all about. And as from me, I think that was the time I had with you. It has come to an end. Keep well. Bye-bye.